we're solving systems. So when solving a system of equations by graphing, it's often easiest if both equations are written in slope-intercept form. In fact, if we're going to graph, that's the form that we really want them in. All right, so when we look at these two problems down here, let's look at A. My first equation, already in slope-intercept form, it's nice, I can go ahead and graph it. So my y-intercept is at -1, and my slope is 2, which means I'm gonna go up 2 and to the right 1. And then I'm gonna go back to my y-intercept and go down 2 and to the left 1. I'm gonna draw my line. Okay, but my second equation is not in slope-intercept form. So what do I need to do to get it into slope-intercept form? What do I need to do first?
Add the 4x.
Yeah, I'm gonna add the 4x. Now, can I put it underneath this 4 here?
No, you have to put it to the side.
Yeah, I'm gonna put it back here, and then when I actually do the addition, I'm gonna bring down my 2 while I'm gonna kind of scoot my stuff over. And I'm gonna write my 4x first. Why am I putting my 4x first? Yeah, because I want it to look like slope-intercept form, so I just swap the order, doesn't matter. Okay, just have to make sure that I keep the correct sign with it. Okay, now what do I need to do? I divide everything in my problem by 2. So I have y is equal to 4 over 2 gives me 2x plus 2. Alright, so now I can graph this one. So I've got a y-intercept at 2 and a slope of 2, which means up 2 and to the right 1. And then I'm going to go backwards. And there's that one. Alright, so what do we see here? Those lines are parallel. So what would I be writing for a solution on that? That line's a little wonky over there. What would I do for my solution? What would you say? Okay, but what does a solution to a system mean? The point of intersection. So if they're parallel, what does that tell me? They're never going to intersect, so I won't have a solution. Does that make sense? Okay, so right down here in part A, that's what they're asking you about. So the lines are parallel. So I'm going to write my little symbol there. All right, so there will be no solution because they're not ever going to intersect. All right, so I'm okay if you use that symbol right there for no solution. I think we've already talked about that this year, yes?
Yes.
Okay. All right, so now let's look at the next one over there. My first equation up there, I can go ahead and graph it, yes? My y-intercept is at -2, and I have a slope of -1. Okay, so it looks like this. Okay, and then my second equation though, again, not in slope-intercept form, so what am I gonna need to do? Good, I'm gonna subtract the 6x, I'm just gonna kinda write it back there behind the 12, but when I actually do it, I'm gonna write it in the correct order, so just be careful with your signs there. Because the 6x is negative and the 12 is negative, so you make sure both those have the right sign. Alright, now I need to divide everything by 6, okay? So when I do that, I get y is equal to -x minus 2. Well, if I go to start graphing that, what's going to happen?
It's the same.
Yeah, it ends up being the same line, right? Make sure when you draw a graph, you put arrows and stuff on it. Okay, so that's pretty much what B says, that they are the same line. Okay, so what do you think I would write as the solution? Yeah, so we're gonna write it this way. So it is kind of all real. So there are infinite solutions. So we use all reals pretty frequently. We also can use the infinity symbol to represent all reals. Especially like in solutions, we usually, when we're talking about the graph, we're gonna use infinities there normally. But either one of those would be okay. Everybody all right there? Okay, so our options then for a system is I can have one solution, which is what we looked at yesterday, where the lines have different slopes and they intersect in one location. And we write that as X, comma, Y as an ordered pair. Alright, we can have no solution when the lines have the same slope but different y-intercepts. So we would probably just write this, they're parallel lines. Okay, or we can have infinite, it says infinite many, I'm not ever gonna make you write infinite many. Alright, that sounds weird to me. Alright, infinite many where the lines have the same slope and the same y-intercept, so they are essentially the same line. And again, either infinity or all reals, either one is okay with me. Probably in this case, I would say infinity, but I would take all reals. Alright, so we've got the same thing happening here. I'm not gonna do one, I'm gonna skip over and do number two, okay? So if we look at number two, the very first one right here, what can you tell me about that one?
It goes to the origin.
It goes to the origin, and we know that because
There's no y.
there's no y-intercept back there, so the y-intercept must be zero. It doesn't mean it doesn't have one, it means it's zero. Alright, then I'm gonna do what to get my next point? Where do I go? Up 3 and over which direction? To the right 2, okay, good. Alright, and then I'm gonna go back and I've gotta go down 3 into the left 2. You'll be really careful about that. And here's the deal, if you're struggling with graphing, you have a graphing calculator that you can use. Okay, so there's that one. Alright, what about the second equation? What do I need to do?
Add the X to it.
Good, I'll move my x over. Okay, so I've got 2y is equal to, and I'm gonna write that as x minus 8. Now I need to do what? Divide by 2. So I end up with y is equal to 1/2 x minus 4. Are we okay there? Alright, so I've got a y-intercept at -4, and my slope is what? 1/2, so how do I graph that?
Go up
one
to the right.
Up 1 and to the right 2, good. Alright, and then I've gotta go back to my y-intercept, and I'm gonna go down 1 and to the left 2. And so far, this is still pretty nice, alright? So, here is my intersection. How do I write my answer? What's it gonna look like? -4 and -6. Okay. And remember, I can go back and plug in -4 for x and -6 for y, and the left and the right should be equal, and it should work in both equations. Everybody okay? Alright, any questions so far? Everybody's good? Alright, it's kind of what we were doing before. So, okay, number 3, they want us to solve the system of equations by graphing. So this time, neither one of them are in the right form. So let's look at the first one. What do I need to do on the left side, on this equation? Subtract 3x.
Yo, dang paper.
Alright, leaves me with 6y is equal to -3x minus 12. Okay, now what? Divide both sides by 6. Okay, so I've got y is equal to -3 over 6 is going to give me -1/2 x, and 12 divided by 6 is going to give me -2 back there. Everybody okay there? Alright, the other one, what do I need to do?
Just divide by 2.
I just have to divide by 2 here, so it's a little simpler. Alright, so I have y is equal to 1/2 x minus 2. What do we see here? They're the same line, so what am I going to write as my solution? Yeah, I already know it's going to be infinite. I'm only going to graph it once. I'm not going to trace it a second time. That's silly. Alright, but we do have to put it on the graph. Alright, so I start with a y-intercept at -2, and I have a slope of -1/2, so I'm going to go, it's a -1/2. Down 1 and to the right 2. Then I'm gonna go up 1 and to the left 2. I mean, I guess you could go to the left first. I always do. I always go to the right first, so. Alright, so then, I'm gonna use a ruler so my line's not crazy. Make sure your lines have arrows on the ends, don't be lazy. Okay. Good there? Alright, let's look at 4. The graph line below represents an equation in a system with no solution. Write a possible second equation. Alright, so if it has no solution, what does that mean? Okay, they must be parallel, so what do we know about parallel lines? Okay, same slope, different y-intercept. Okay, so what is the slope of this line then? Let's see, if I draw my triangle right here, it looks like I'm going down, so that's -1. -1/4. Alright, so I need a line with a slope of -1/4. Alright, so as long as it has -1/4 as a slope and the y-intercept is not 3, it's correct, right? So what did you write? Plus what?
1.
Plus 1, that works. Are we okay there? Okay, and it doesn't tell me that I have to write it in any other form, but what if I wanted to? What if I had to write the parallel line in a standard form? What would I need to do then? You may know the standard form. AX plus BY is equal to C, alright, which means I would need to do what here?
Add the 1 to the other side.
Yeah, I'm gonna move my 1/4 over, so I'm gonna add it to both sides. So that gives me 1/4 x plus y is equal to 1. Now, technically, that's not in standard form because my a value needs to be a whole number, so how do I get rid of the denominator? I'll multiply everything in my problem by 4. Everybody okay there? So 1/4 times 4 would give me 4x, y times 4 would give me 4y, and 4 times 1 would equal to 4, sorry, this is 1x, sorry, my fault. 4 times 1/4 is 1, sorry. Everybody okay with that? And they didn't ask me to graph it, so I'm not going to. Are we all right there? Now, if you have to do this on yours, I'm not gonna make you do it in standard form, but I wanna make sure that we're still comfortable with standard form, because we're still gonna be using it. Okay, so if we go over here to number 5, Tish believes that the linear equations shown do not have a solution because they do not intersect. Do you agree or disagree, and why?
I disagree.
Okay, why?
Because the lines are not parallel.
Okay, they're gonna intersect eventually. So what we have to look at is not necessarily the part that you see, we're only seeing a snapshot. It's the same thing on your calculator when you graph two things. You're seeing a snapshot of that window, but the graphs are gonna continue on, so we have to know what they're gonna do as they continue on. Is everybody okay there? Okay, so we're gonna say we disagree. And I'm gonna write what Corbin said, because the lines are not parallel. And they're not the same line, obviously, so they will eventually cross. Everybody good there? Okay. Number 6, circle the names of 2 students whose equations would have infinitely many solutions. So what does it mean to have infinitely many solutions?
They're gonna have the same line.
They'd have to be the same line. And these are they all in standard form? Yeah, they are. So, okay, to be the same line, that means I can multiply something to make them equal. Are we okay with that? So I could rearrange them all into slope-intercept form. There's nothing wrong with doing that. Or I could look and see what my relationships are. So if I look here, 2x and 2x are the same, but if these signs are different, when I rearrange, they're not gonna end up with the same sign. Does that make sense? The signs would have to match. Are we okay there? Alright, plus, if I think about a single, like this is a single Y, then this would also have to have a single Y, so there's no way these two are the same. Are we okay in that? Alright, so let's look at these two. We don't know which two, but we're gonna take a look. So, could I multiply this one times something and make it match? Okay, what could I multiply by and make it match? Okay, so if I multiply this by -2, it'd give me -4. If I multiply this by -2, it'd give me +2. So do these two match? Okay, so those two do. Alright, so let's look at these two. So 6x, could I multiply this one by something to get to it? Because this one's bigger, so can I multiply this one by something to get here? Okay, so if I multiply this times 3, it gives me 6x. If I multiply this times 3, does it give me 6y? So this one doesn't match any of them, so penny's out. Does that make sense? Okay, so now let's talk about Robbie. Can I take this one and do something to it to make it equal this one? Alright, let's try that. So 2 times -2 would be -4x. 3 times -2 would be -6y. 3 times -2 would be -6. So far these match. So let's see if this one, is there a way to get from here to here? Like 2 times 3 gives me 6, but 3 times 3 doesn't give me 6, so this one's also out, so it means it had to be these two. Now, if I rearrange them both into slope-intercept form, so pick one, we're gonna rearrange one. I'll start with, we're gonna do Robbie? Okay, so what do I do first? So I'm gonna subtract 2x from both sides. So that goes away, and I have 3y is equal to -2x plus 3. Then I would divide everything by 3, and I'll just write it next to it, and that's gonna give me y is equal to -2/3 x plus 1. So, there wouldn't be anything wrong with changing every single one of them. Yeah, it just takes longer. So to get from here to here, all we really need to do is multiply by, I probably should have written it in my X mark. Yup, that means, y'all are ahead, that means multiply by times -2, right? Yes? Okay, on 7, Abby bought a combination of streamers and balloons for a birthday party. The number of balloons Y was 3 less than 2 times the amount of streamers purchased X. If Abby bought a combination of 9 balloons and streamers, the following system can be represented by the situation. Alright, I do want to talk about this for a second. So, like y'all are gonna have to write these relatively soon, like that's coming. And you're gonna have to be able to read that and write these in two different equations. So when I know she bought a combination of streamers and balloons, that's just an X and just a Y because it doesn't have any quantity attached to that. Are y'all okay there? Then it says the number of balloons was 3 less than 2 times the amount of streamers. That's your second equation right here. Are y'all okay there? And then it said she bought a combination of 9 balloons. This actually goes back to the first part. A combination of 9 means some of these and some of these. Are y'all okay with that? Alright. So anyway, we've got this system. We need to solve it. So neither one of them are in slope-intercept form. So this one, what do I need to do? Subtract the x. Okay, so then that leaves me with y is equal to -x plus 9. What about this one? It's already good. Alright, so I'm going to go ahead and graph this one right here. Alright, so I got x plus 9, so positive 9 up here. It has a slope of 1, so, oh my gosh, that's a lot of dots. Oh, it's -x, sorry, thank you. You were absolutely correct. They should have really done this as it's a real world problem, so it really should have been on a quadrant 1 anyway. But we're going to write that as is. Because technically it would end when I get to 0 down there. That's what they gave me. Okay. Then this one, I'm going to graph. So where do I do with this one? Down here to -3, it has a slope of 2, so up 2 and over 1. To the right. Go back and graph the rest of it. I said, this really should have been a quadrant one only graph. Okay, so something like that. Alright, where is my solution at? 4 and 5. Okay, so my solution is at 4 and 5. Alright, so it says solve the system by graphing and find the number of each item that she purchased. So I have a combination of streamers and balloons. Streamers was my X and balloons was my Y. So I purchased 4 streamers and 5 balloons. Are we okay there? And I could check it in my other problem and it would absolutely work. Everybody good?